Good evening, my dear students. Welcome to HashLearn Studios. My name is Dheeraj. I'm a chemistry teacher for the day. And today's concept under discussion is phosphorus and its compound, part 1. And this belongs to the lecture series JEE and NEET. So quickly moving ahead, let me tell you what happened in the previous class of mine. In the previous class of mine, we looked at group 15 elements, that's nitrogen and its compounds. And we did some numerical problems pertaining to nitrogen and its compounds. In today's class, moving ahead, before I tell you what will be today's discussion about, let us quickly look at the important CPP question that we had picked up from the previous class. So we have asked you this. We had asked you this question: red phosphorus can be obtained from white phosphorus by. So we had asked you a pretty straightforward question. So it is theoretical. Heating it with a catalyst in an inert atmosphere, distilling it in an inert atmosphere, dissolving it in carbon disulfide, that's CS2, and crystallizing, melting it and pouring the liquid into water. So you should know that white phosphorus is something that naturally exists in nature. So white phosphorus can be converted into red phosphorus by heating it in the presence of a catalyst, which is usually an active metal. So that's the answer that's given up for you guys. We have Sakshi joining us as the first participant of the webinar. Sakshi, a warm welcome and a great good evening. Moving ahead, I would in today's class want to discuss about phosphorus and its compounds, guys. I have included some nitrogen based compounds also. We will have two classes of mine today within a gap of 15 minutes. So in the first class, we will look at nitrogen and partly phosphorus. In the second class, we'll be concentrating on phosphorus compounds more. So I've picked up some refined problems from nitrogen. I've introduced it here. So let's get going. The next slide that you would be seeing is the first question for the day. Like you guys know the drill. I'll give you the background information and the theory once we look at the question. Moving ahead, the first question for the day. Go for it, guys. The value of delta H VAP, that stands for enthalpy of vaporization. So the value of enthalpy of vaporization of ammonia is attributed to it. So we're asking you, or we are telling you as a matter of fact, that the enthalpy of vaporization for ammonia is high, and we are asking you what is the reason for enthalpy of vaporization to be high. So we have given you four options, guys. Basic nature, association due to hydrogen bonding, that's hydrogen bonding, shape, covalent nature of the NH bonds. So what is it really going to be, which can be attributed to the high value of enthalpy of vaporization? So if you recall what is enthalpy of vaporization, it's basically the heat needed to vaporize ammonia, and that we are telling you is high. So it is because of what is the question that we are asking. So we have basic nature, association due to hydrogen bonding, shape, covalent nature of NH bond. So hydrogen association due to hydrogen bonding, what is it? Sakshi gives us the right answer. Yes, it's definitely due to association of molecules among themselves due to hydrogen bonding. Simple. Basic nature has nothing to do with its physical property. Shape again doesn't matter too much. Covalent nature, we know that covalent bonds, NH bonds, are covalent in nature, and they're also polar, and since they are polar, there's hydrogen bonding happening. So covalent nature is also not a complete answer. The complete answer is hydrogen bonding. So if you have three bonds, NH, NH and NH, if you have to break them, along with that there is the hydrogen bonding between nitrogen of one molecule and hydrogen of the other molecule. So this has to be, so if you take ammonia molecule is pyramidal in nature. So one nitrogen molecule is going to bond a temporary hydrogen bond with hydrogen, and the next hydrogen with the next nitrogen. Subsequently it goes on increasing. Therefore bonding is high. The temperature needed to convert them into vapors also will be high. Pretty straightforward there. So Sakshi gives us the right answer. Welcome to the webinar, Peru. So covalent nature, like I told you, Pero, is one of the attribute. It is not the final answer. It is covalent, yes. It is polar, yes. Due to its polar nature, it has a positive end and a negative end, due to which there is hydrogen bonding. So all this is interrelated. So covalent bonding or the covalent nature is just the beginning of the discussion. So moving ahead. Second question, the number of POP and POH bonds present respectively in pyrophosphoric acid molecule. So once you know pyrophosphoric acid molecule, you should be able to write the structure. Once you are able to write the structure, you should be able to give us the answer pretty quickly. So pyrophosphoric acid. So 1 2, 2 2, 1 4 and 1 8 respectively. Which one is it going to be? POP, we are talking about phosphorus, oxygen, phosphorus and phosphorus, oxygen, hydrogen bond. With regards to pyrophosphoric acid molecule. So what is it going to be? Quickly guys. If you want, I can help you with the molecules formula. That might make your work a little easier. It's PH4P2O7. This is pyrophosphoric acid for you. Pyrophosphoric acid, H4P2O7. So Sakshi says it's 2C. Okay, let me give you the structure really quick. The structure is going to be this. You should know that phosphorus has a maximum covalency of 5, so it is capable of forming 5 bonds, and it does form 5 bonds here. This is how the pyrophosphoric molecule will look like. So if you look at POP bond, there is one POP bond, and how many POH bonds? 1, 2, 3 and 4. So the answer is 1, 4, and good Sakshi, you were right once again. Moving ahead, let's look at the third question. Among the oxoacids given below, the correct decreasing order of acid strength is. So we have given you the oxoacids of nitrogen family. We have given you nitrogen, phosphorus, arsenic and antimony. So we are asking you which one is going to be the most acidic, or we are asking you the trend, the decreasing order of acid strength. Go for it. H3ASO4, H3SB, that's antimony, and HNO3 and H3PO4. Which one is it going to be? 4, 3, 2, 1. 3, 4, 1, 4. And what is it going to be? See, maybe you can correct this too. 3, 4. So you have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and there's 2 4s. You can correct this to 2. So 3, 4, 1, and make it 2, guys. Make it 2. So all the 4 numbers are present. So I've corrected it, Sakshi. So just check whether you're going to change your answers. So it's 3, 4, 1, 2. So we have Preeti joining us. And yes, Sakshi, you're right. Excuses for that, guys. So we have B as the answer. It's 3, 4, 1 and 2. The reason is pretty straightforward. You will know it very well yourself. Acidity decreases as we move down the group. Acidity decreases as we move down the group. Because why does it have to decrease as we move down the group? Because as we move down the group right from nitrogen till antimony, the size of the atoms goes on increasing. If the size of the atoms increases, its electronegativity decreases. Electronegativity decreases and associated metallic character increases. So all of this will make the molecule less acidic, and it will increase the basic properties. So acidity will increase as we move down the group. So Sakshi and Preeti, who has joined us, have given us the right answer. Moving down, pretty straightforward to remember, guys. Last time we were speaking about basicity. Now we are shifted it to acidity. So moving ahead, the fourth problem for the day, the first numerical. Which of the following halides of group 15 elements does not exist? Pretty straightforward, easy to answer. Which of the following halides of group 15 elements does not exist? We have NCl3, BiCl3, bismuth, BiCl5 and PCl5. Which of it? We have Sushmita M also joining us. Welcome, Sushmita. You've joined us at the right moment, even though a little late, it is fine. We have a good number of questions packed for today. So which of the following halides of group 15 elements does not exist? NCl3, BiCl3, BiCl5 and PCl5. Which one? Sakshi says it's 4A. Waiting for others to quickly give me the answer, guys. So Preeti says it's 4C. Okay. Others, Peru, and Sushmita who joined us now. Go ahead, guys. Go ahead. Work on this problem. Let me know the answer quickly. And NCl3, it is definitely possible to form NCl3. So is BiCl3. So is PCl5, phosphorus pentachloride. It is not easy to form, or it is not at all possible to form BiCl5, bismuth pentachloride, because due to inert pair effect, bismuth will always exist in +3 oxidation state. It will not exist in +5 oxidation state. So bismuth is the last element in the nitrogen family. So it will have the maximum inert pair effect, and you should know what is inert pair effect. It is the reluctance of the s electrons to take part in bonding. So nitrogen family has general configuration ns2 np3, so only these three electrons take part in bonding, and BiCl3 can be easily formed, and these two electrons of s will not take part in bonding. Therefore +5 oxidation state is not possible. Hence we can outrightly tell that BiCl5 will not be cannot be created in the lab, and therefore will not exist. So it is due to inert pair effect seen in case of nitrogen family. So that's the answer. It is BCl5. It doesn't get formed, hence this is the answer, guys. Moving ahead, a little breathing time for you guys. Look at this question. So which nitrogen trihalide is least basic? So we had asked you which nitrogen trihalide is least basic. The options were NF3, NCl3, NBr3 and Ni3. Pretty much like we had discussed, like we are discussing acidity. Now we were discussing about basicity in the last class. So it was Samriddhi who gave us the right answer. Then Samriddhi has not joined us today. Congratulations, Samriddhi, you have won yourself one atom session. So we had pretty much dealt with some of these questions in the last class only, and then I tried to incorporate this as a contest question. So a couple of you gave me the right answer, but the fastest one to give the answer was Samriddhi. Congratulations to you once again. You have availed an opportunity of encashing one of our atom sessions. So moving ahead, the next slide that you would be seeing is the current classes contest question. You know the drill, guys, but let me quickly recall that for you. The fastest one to give us the right answer will be awarded an atom session, which gives you an exclusive access to get one of your concept, a difficult critical concept or a question answered by our in-house experts within 20 minutes of posting the question. So here we go. The next slide is the current classes contest question with 60 seconds timer. Here we go. Which of the following is arranged in the increasing order of enthalpy of vaporization? I've given you a little idea about enthalpy of vaporization. That was the first question for today. Here we go. So we have phosphine, arsine, ammonia. Then arsine, phosphine, ammonia. So we have mixed and matched, and you have to tell us in the increasing order of enthalpy of vaporization, which one is it going to be? Go for it. She says it's Z. Okay. Increasing order, guys. 15 seconds left. So what is it going to be? So time's up. Preeti also says it is Z, increasing order of enthalpy of vaporization. I just told you guys that what you will be thinking about when you're thinking about enthalpy of vaporization, you should be thinking at the magnitude or the amount of bond strength. So that should be able to give you the answer. So we will discuss about this. The right answer and the winner will be declared to you in the next class of mine, which is in 15 minutes after this session. So it is not a pretty long wait. You'll get to know the answer as well as the winner in the immediate class of mine in today's class. So moving ahead, the correct order for the increasing acidic strength of oxides of nitrogen. Pretty straightforward question. You should be able to give us the answer. The correct order for the increasing acidic strength of oxides of nitrogen. So when I take the same elements oxides, which parameter should I be looking into to look at the increasing strength of acids or acidic property? So which property will I be looking at? So you have N2O, N2O3, N2O4, N2O5 and NO. Which one will I be worried about? Quickly, you have 10 seconds remaining, guys. acidic strength, and we are dealing with oxides of the same element. Which one is it going to be? So time's up is what the clockmaster says. Oxides of nitrogen, we are worried about acidic strength. So if you're thinking from your end, let me quickly help you with it. You should always remember that if you have the same elements oxide, so if I'm comparing one element's oxides acidic properties, then I can say acidic property is directly proportional to oxidation number on nitrogen, or for that matter can be any central atom. So you should be looking at the oxidation number of nitrogen. So higher the oxidation number, higher will be the acidity. That way you should be able to give us the answer pretty straightforward. It is option B, because oxidation number of nitrogen is +1, in this case +2, in this case +3, in this case it is +4, and in this case it is +5. So as the oxidation number goes on increasing positively on the given central atom, its acidic property also increases. Or you can compare it in this way also. If the number of oxygens associated with the central atom also increases, the acidity increases. Both are same. If the number of oxygens associated increases, it means the negative charge, the atom which is giving us a negative charge, is increasing. So that inversely means that the positive charge or the oxidation number of nitrogen is becoming more and more positive. So both means the same. Acidic property or acidity is directly proportional to the oxidation number on nitrogen in this case, or generally it can be any central atom. So moving ahead, hope you have understood, guys. Moving ahead, which of the following will produce a black precipitate with aqueous NH3 solution? The question that I have for you guys here is, which of it will produce a black precipitate with aqueous ammonia solution? Think about it. So unfortunately nobody were able to give us the right answer for the previous question. No issues. Think about it, guys. You would have come across this question. It has been repeated twice in some of the national level examinations. So go for it. You have ferrous sulfate, you have mercurous chloride, zinc sulfate, and ferric chloride. Which one will react with liquid, that's aqueous ammonia, to give us a black precipitate? So which one is it going to be? Think about it. Meanwhile, take a couple of more seconds. We can afford that. So which one is it going to be? Sakshi says it's 6D and Preeti says it's 6C. Let me quickly give you the reaction, guys. The reaction is, it's option B. Mercurous chloride reacts with ammonia to give us mercury in the metallic form and Hg NH2 Cl plus NH4Cl. So it's a disproportionation reaction where mercury is both reduced as well as oxidized. So this is the black precipitate that is utilized. Now it has varied application, but the application is beyond your scope of realm right now. In second PUC you'll not worry too much about it. That's 11th and 12th, you're not going to worry about it. So the black precipitate can be used as a ceramic material in making reverberatory furnaces, vessels, and basically it is high melting point material can be made from this compound. Therefore it is that reason makes this compound really commercially important. That is why we have asked you this question, guys. So the answer is option B. So remember these reactions. I know that it's not normal to logically arrive at these reactions, but you have to know some of them which are practically as well as academically important for us. Moving ahead, 7th question. Nitrogen form N2 but phosphorus is converted into P4 from P2. The reason behind this, pretty straightforward question. You should have asked this yourselves a couple of times. When nitrogen and phosphorus are in the same group, when nitrogen can exist as N2 molecule, why is it that phosphorus does not exist as N2 molecule, that's P2 molecule? Why should it convert itself into P4? So that's the question that we have asked you here. Go for it. Why should phosphorus be in P4 form and not in P2 form? So is it because the pi-pi bonding that you see in phosphorus is strong, or is it because the pi-pi bonding that we see is weak? Multiple bonds is formed easily. Multiple bond is formed easily means the pi-pi bond is strong. Triple bond is present between two atoms. So what is it going to be? So Preeti gives us the answer first. She says the pi-pi bond is weak. Yes, she is right. It is definitely option B. Now what happens is, due to increase in size, if you look at nitrogen, as we move down the group from nitrogen to phosphorus to arsenic to antimony and bismuth, the size of the atoms goes on increasing. With increase in the size of the atom, the extent of overlap becomes less. So once if the extent of overlap is less, the formation of the pi bond, even though they are formed, the formed pi bonds are very, very weak. So I'll repeat again, guys. As I move down the group, the size of the atoms increase. With increase in atomic size, the overlap extent or the extent of overlap is very less, due to which the formed pi bonds are very weak. So if they are weak, what do? Well, why should it convert itself into P2 to P4? If they are weak, they will not exist as a triple bonded compound, because if it is a triple bonded compound, it will take up the sp hybridization, which is planar. Or if it has to shift itself into P4, it will convert itself into sp3 hybridized atom. Therefore, since my pi bonding is weak, I will prefer, me as that phosphorus will prefer to change into a different hybridized state and undergo geometry change, which gives me stability, and that geometry is tetrahedral. So if you take phosphorus, the phosphorus now changes its hybridization state and it is bound to 3 other phosphorus groups. So every phosphorus will be bound to 3 other phosphorus group in a tetrahedral manner. This is because the pi bond that gets formed is very, very weak compared to that of nitrogen, where nitrogen can very conveniently form triple bonds due to its smaller size and better overlap, and here it is weaker due to its bigger size and less extent of overlap. So the answer is pi bond is weak, and this is the extra information. It forms a sp3 hybridized structure which is tetrahedral in nature. So good, Preeti and Sakshi gave us the right answer. Moving ahead, guys, moving ahead, look at the 8th problem. Might take you a little time, but no worries, read the question thoroughly. A solution of colorless salt H, so we are naming our salt H, on boiling with excess NaOH produces a non-flammable gas. The gas evolution ceases after some time. So gas evolution ceases after some time, and next what happens is, upon addition of zinc dust, so now I'm adding zinc dust, now the gas evolution restarts. Therefore the colorless salt H is R. Let me quickly tell you before you start working on it. It is a multiple correct answer question. So I picked up this because the question seems to be really interesting, and I want you to understand, and I want to personally give you a thorough idea of these reactions. So therefore, let me tell you, it is a multiple correct answer question. So you have more than one right options, guys. Think about it. Salt boiling with NaOH. Then there's a gas evolution. It ceases after some time. Then I add zinc. Again the evolution starts. So we are asking you to predict the starting material. Which one is it going to be? So meanwhile, if you're working from your end, good. Let me quickly give you a basic idea about it. I'll write down the reaction so it becomes very easier for you to understand and keep it in mind. So I start with, the right answer is A and B, guys. It's ammonium nitrate and ammonium nitrite. So I'll give you the reaction. Ammonium nitrate reacts with NaOH to give you ammonia. So Sushmita says it's D. Okay, so A and D. So Preeti was close, but it is A and B, Preeti. Good. So it gives us ammonia plus NaNO3 plus water. This is the first set of reaction. So the evolution of gas, if you see, boiling with excess NaOH produces a non-flammable gas, that is ammonia. Next is, after some time, the evolution of gas ceases because pretty much the entire ammonium nitrate is converted itself into ammonia and sodium nitrate. Next, what happens is, the moment I add zinc, the moment I add zinc, the sodium nitrate that is formed, the moment I add zinc, the sodium nitrate that was formed will convert itself into ammonia again, will convert itself into ammonia plus Na2ZnO2 plus water. So again the evolution of gas starts. This is with respect to NH4NO3. I told you that NH4NO2 is also right. If you want to look at that reaction, NH4NO2 will react with NaOH to give you NH3 plus NaNO2 plus water. So instead of, the first step is similar. Instead of sodium nitrite being formed, I'll get sodium nitrite, which then can further react. Now if I add zinc, and zinc plus this entire thing together will further break down to give me the same product. Instead of Na3 you will have Na2ZnO2 plus ammonia plus water. So if you can know one reaction, the other reaction can be pretty much understood very easily. So the answer is both A and B. A couple of you gave me only half the right answer. Peru and Preeti said it is A. Good guys, extend that to B as well, and there you have the complete scenario in front of you. Hope you have liked the question. Seemed to be a pretty interesting question for me. Moving ahead, another similar type of question. An orange solid on heating gave a green residue. B, it gives us, I'm heating a compound, it gives me a green residue, a colorless gas and water vapor. So the dry gas on passing over magnesium gave a white solid, and D, on reaction with water, gave a gas E, which formed dense white fumes with HCl. So we are asking you to identify A, B, C, D and E respectively in this case. So have a detailed look at this question. And we have Shishmita asking us a question. Okay, guys, work on this question. Meanwhile, I'll quickly go back to that question to answer her query. She's asking, why not ammonium sulfate? It is pretty simple. If we are worrying about only the first step, that is, if I have production of a non-flammable gas on reaction with NaOH, I can take NH4 twice SO4 also, I can take ammonium sulfate. But if you look at the second case, after addition of Zn dust to the same solution, the evolution starts. If you look at the reaction, Zn has to have sodium nitrate or sodium nitrite in order to start producing the material again, that is to start producing ammonia again, which would not be possible in case of ammonium sulfate. So ammonium sulfate can undergo only the first round of reaction wherein it can give out ammonia, but the second sustained production of ammonia after adding zinc will not be possible. It is quite evident from the reaction. Look at it and let me know if I can help you in any other way. Shushmita. Moving ahead. So who gives us the first answer? We have Shlok Suman joining us on the 9th question. So Shlok says it is C. Peru says it is A, and Sakshi also says it is A. It is pretty straightforward, guys. You shouldn't be worrying too much about this. Now, if you look at the first information that I have is formation of, I'll underline that for you, formation of dense white fumes with HCl. If it has to form dense white fumes with HCl, it has to be ammonia, because it is ammonia which forms dense white fumes when you bring it in contact with HCl due to formation of NH4Cl. That step makes my answer really easy to be solved. Question. So if it is ammonia, I have identified it as ammonia. Next, if you look at that, ammonia is formed by hydrolysis of a solid D. So if you look at that, the previous case, E is ammonia and ammonia has to be formed from D. So D is reacting with water, that's hydrolysis, and it gives me E. So what on hydrolysis can give me ammonia? If you look at it, it should be magnesium nitride. So magnesium nitride on hydrolysis will give me ammonia gas. And then going back again, what gives me magnesium nitride? So a dry gas on passing over heated magnesium gives me a white solid. So that if that white solid is magnesium nitride, obviously if it is magnesium as mentioned in the question, the other thing has to be nitrogen gas. So when nitrogen gas is made to pass through hot magnesium, you end up with magnesium nitride. Move back again. So we have got E, D and C. A green residue and a colorless gas C and water vapor. So we have found out C has to be nitrogen, the colorless inert gas, and green residue. Keep one thing in mind, anything with response to bottle green or a little dark green colored compounds, it has to be chromium based compounds. So if you look at that, it is chromium trioxide or chromic trioxide, which is green in color, the green residue. After that, it becomes little easy for us, and this entire thing obviously has to come from ammonium dichromate. So you have to work on one clue that you know. The easiest, I would say, the easiest catch statement here is it forms dense white fumes with HCl. From your practical knowledge, that's in your lab knowledge also, you'll be able to tell that it is ammonia which forms dense white fumes with HCl. From there, working backwards becomes easy. Ammonia, source for ammonia, it has to be a nitride. Okay. Now source for nitride, it has to be nitrogen gas because it is colorless and inert. Source for nitrogen, we'll be able to go back and look at it once again and get the complete answer. So I hope you guys have understood good. So it was Peru and Sakshi who gave us the right answer first. So it is ammonium dichromate followed by this. Others, I think Preeti and Sushmita, you guys got a little confused with the order maybe, because the option B also has the same species as in option A, but the order is different, and order is very important in this question. So hope you've understood the details behind this question. Moving ahead. So the next question is a pretty important question, and you can answer it easily also. Which of the following is produced when lead dioxide is added to the boiling solution of manganese sulfate containing nitric acid? So we are asking you, which is the source for the production of lead dioxide? So what can I be using to produce lead dioxide is the question. So you have three options, and you should be adding all of them individually to a boiling solution of manganese sulfate in the presence of nitric acid. So which one is it? So which one is it going to be? And let me quickly tell you, this is again a multi-option question, guys. This is again a multi-option question. So what is it going to be? Shlok says it is C. Okay, let me give you the reaction. Little complex reaction, but try to keep it in mind. It's a multi answer question. So the reaction is like this: MnSO4 plus PbO2 in the presence of nitric acid. So I have taken manganese sulfate and I have taken nitric acid, and it is lead oxide. Now quickly it gives me HMnO4 plus PbNO3 twice plus PbSO4 plus H2O. If you want me to balance the reaction, this will become 2, then 5, 6, 2, 3. Yes, Pb. How many times? Okay, 3, and this will be 2, and here we go, 2. So which gets created if I have to boil lead dioxide with these, all of this? You have HMnO4, you have lead nitrate, and you have lead sulfate. So A, B, and C, all of these gets produced during this reaction, guys. Quite an informative question. Here's the reaction for you. Moving ahead. This is the 11th question. Which acid will you use to dissolve lead oxide? So I've asked you about lead oxides here. Which acid will you use to dissolve lead oxide? Is it nitric acid, sulfuric acid, HCl, or none of these? With some basic chemistry of these acids, you should be able to answer questions like these. So you don't have to remember the reaction in specific. So it's a single right answer question. So there's just one right answer for this. I'll let you know in case there's multiple. I'll choose questions like those when it covers a good sequence of concepts. So which acid will you use to dissolve lead oxide? HNO3, H2SO4, HCl, none of these. Which one is it going to be? So what is it going to be, guys? So Preeti says it's A, and Sushmita says it's D. Let me quickly tell you, the right answer is nitric acid, because nitric acid, what happens is the moment lead oxide dissolves or reacts with nitric acid, it forms a water soluble lead nitrate solution. Water soluble lead nitrate solution. If you take H2SO4, it forms lead sulfate. Lead sulfate forms an insoluble layer. What happens is, if as you try to dissolve lead oxide in sulfuric acid, it forms an insoluble layer of PbSO4, and that insoluble layer formation prevents the further dissolution of lead oxide in sulfuric acid. So it cannot be sulfuric acid. HCl, the same thing. The moment PbO reacts with HCl, it forms a layer of PbCl2. This layer, which is insoluble, prevents the further dissolution process of lead oxide. Therefore, it has to be nitric acid, wherein it readily dissolves, forming a water-soluble lead nitrate solution. So, Shlok gives us the answer right the second time. Nitric acid, good. Sakshi, and we have Pallavi joining us at the neck movement of this session. No worries, Pallavi. You've joined us with a bang. So, Preeti, Pallavi, Sakshi, and Shlok gives us the right answer. Now, this is the last question for today's session, guys. You have another session to follow within a gap of 15 minutes. So the last question for the current session is, consider the following reaction. We are asking you to look at the following reaction, and we are asking you to predict the role of NO2. So this is also a multi right answer question. So there can be more than one right answer here. There can be, and there is more than one right answer in this question. So read the question carefully, guys. So we are telling you that there is sulfur dioxide, which can be oxidized to sulfur trioxide, and therefore there we have given you another set of reaction below. What would be the role of NO2 is the question under discussion. What would be the role of NO2? So have a look at it. So what would NO2 predominantly be doing in this case? Pretty straightforward question, guys. So what is it? B and C. So Shlok says it's B and C. It can act both as an oxidizing as well as a reducing agent. Shushmita says it is C. It's a multi right answer question. Let me tell you, in this case, if you look at the first reaction, it is pretty straightforward. It is pretty straightforward that it will be acting as an oxidizing agent. So first step, it is acting as an oxidizing agent, where SO2 is oxidized to SO3. So nitrogen dioxide itself is getting reduced. So it is acting as an oxidizing agent. But in the second reaction, you should be observing very carefully that in the second reaction, NO2 is regenerated back. So NO2 is regenerated back. Therefore, its amount remains unconsumed, or its amount remains constant due to constant generation of NO2. So if I'm using NO2 to oxidize SO2, the amount has to decrease. If it is just the first reaction, I can blindly tell it is an oxidizing agent. But if you look at the second reaction, NO2 again is getting regenerated back. So overall, at the end of the reaction, I can tell you guys that pretty much the amount of NO2 remains unconsumed. And which is that species whose concentration or amount remains constant or unconsumed? It is a catalyst. It is acting as a catalyst. And if you look at the phase, the reactants phase and the products phase are all gaseous in nature. Therefore, it can be considered as a homogeneous catalyst. So reaction 1, oxidizing agent. Reaction 2, it is regenerating the NO2 material for us, and it therefore makes the material pretty much remains constant, and hence anything that's constant in a chemical reaction for us, we will call it a catalyst. And since the phases are same, all are gaseous, we will call them as a homogeneous catalyst. Guys, it is oxidizing agent and a homogeneous catalyst option, where both are equally right to this question under discussion. So I hope you have understood why homogeneous catalyst is the right answer. So like I said, that was the last question for you guys today. So we had looked at phosphorus and some of nitrogen based compounds, and we saw numerical analogy of how questions can come pertaining to the concepts that we were planning or intending to discuss. So moving ahead, thank you for joining us, and it was really informative, and your participation was good. and looking forward for the same participation. Like I said, we have another class coming up in 15 minutes, so 8:15 the other session starts, and we are going to look at the second part of this, phosphorus compounds exclusively, and we're going to end phosphorus based compounds and the numerical part of phosphorus based compounds. So thank you for joining me on this session. Looking forward for your active participation in the second session also, and till then it's Dheeraj signing off. See you soon.